right, we've got a couple more talks for you today, and I want to invite to the stage Ellie, your MC.
Hi! Very cool stage. This one's slippery, so more fun for all of us. We have two more talks today. We have Soojin up next. Actually, we have one lightning talk in between by Twilio. And closing today, we have Kate with It's Probably Fine, which I hear is a very interesting talk. So up next, Soojin, who is coming all the way from South Korea to be with us. And come, welcome. This is his... This is his second time in New York City in 15 years. The last time he was here was for middle school, so very exciting. He just flew to be here with us, and he's going to be talking to us about ARKit and machine learning. On his day-to-day job, he works on a comics app, and well, here's to you. Thank you.
Okay, hello everybody. My name is Soojin. I'm an iOS developer at WEBTOON. And by any chance, has anyone heard of or uses the WEBTOON app? Oh, okay, one. I expected zero, but that's okay. So WEBTOON app is an app that you can enjoy comics and cartoons made by thousands of professional and amateur authors. And we are experimenting with like animated comics, AR comics, VR comics, and so on. So if you're interested in, you can try. So last year, ARKit 2 came out, and I was really impressed by the technology, and I was really hooked onto it. So I played with it for a while in my spare time, and I decided to make something with it. So I came up with this app idea, and I dove right into coding. And after 6 months, I released this app. And I'm really happy to share my experience and lessons learned along the way. So let me quickly show you a recorded demo of the app. So the experience begins by detecting a bill with the camera, and then you take a selfie, and a few seconds later, your face is on the bill. So actually I was like aiming for this kind of laughters for my friends and my users. And an actual user of my app left me a review on the App Store that he or she put his baby's face on it, and they were really having fun, so I was really happy. And so what's going on under the hood? So I can break it down into 4 steps. Step 1 is detecting a bill, and step 2 is taking a selfie, which involves detecting the user's face. And step 3 is applying image filter to the selfie to match the texture and style of the specific bill. And then you crop out the contour of the face. And then step 4 is anchoring the stylized face image onto the bill so it looks like your face is on the real world bill. So I'll go more into details about each step. Step 1, image detection is done by Apple's ARKit, and ARKit does this really well. And all it takes is adding the images into AR resources folder, as in your XC assets file, and registering those images into the AR session configuration, and it's really just one line of code. And as you can see, the tracking quality is amazing. So the first time, it really felt like magic to me. And the rest of the steps involves machine learning. I actually use total three machine learning models in my app. I didn't make all of them. I used one from AV Foundation and another one from Google Firebase ML Kit. And the last one I made myself using Turi Create. There are abundance of resources out there right now, like even many out-of-the-box models you can online, then you can simply download and put it into your app. So I suggest you first check out the official Apple website. It's a great place to start exploring your options. And like just a month ago, Apple revealed several new ML models on the website, so you can download and put it into your Xcode project. So first, I used AV Foundation's AV metadata face object for real-time face detection. So you can easily enable this feature using AV capture metadata output. There is an enum called face, and you can just set it up like this. And then you can get the frame of detected face through AV capture data output synchronizer delegate like this. So every frame, I have the bounds of detected face. So I use this information to provide a more consistent user experience like this. So when there's no face in the camera, I show the status bar on the top that says, bring your face into view. And if the face is partially visible, I say, place your face in the center. And when the face is fully present in the screen, I enable the capture button. So basically, I did this to because I didn't want users to capture a selfie and then their face is cut off and the result is bad. So next, I also used face contour detection to crop out the face outline. So for this step, you can think of the movie Face Off, if you're old enough to know this movie, and I am. So for this, I had two candidates. So first, ML-Kit for Firebase and Vision Framework in iOS. So I compared them on two metrics, speed and quality. So each had its own advantage. For example, ML-Kit gave me more precise result. It gives me total 36 feature points of the face contour, while Vision only has 10 feature points, and it doesn't cover up to the forehead. However, ML-Kit takes about 20 to 30 milliseconds on my iPhone 10, and Vision only takes about 10 to 15. But I didn't have to run this model in real time, 60 frames per second. So I was willing to embrace the extra milliseconds for better performance. So I picked ML-Kit. So one of my lessons learned is when choosing which model to use, you have to consider which is more important for the occasion. Is it speed or is it higher accuracy? And most of the times, these two are in trade-off. So I suggest that you make a prototype and test the app and see how it affects the user experience, and then pick the appropriate model. So for example, if you want to run the image processing model in real time, such as hand gesture recognition, you have to make sure that the processing time is less than 16 milliseconds, because that's the time you need to make it 60 frames per second, so you don't drop any frame. And third, and the most important and interesting model, is artistic style transfer. So I'm sure those of you who are interested in machine learning has seen something like this. So style transfer is type of a deep learning model that teaches computer to draw or paint in a specific style, like Van Gogh here. And when we input some content image, like this dog, the model paints the image in the new style. So how did I make this? Well, first, machine learning engineers will definitely use one of these tools, TensorFlow or PyTorch. With this tool, you can make virtually any ML models from scratch, but it requires intermediate to expert knowledge on this machine learning. So this couldn't be my choice. So good news for us. Instead, we have these tools that Apple made for us, CoreML and Turi Create. They let us easily create custom models from one of the predefined tasks like these. So like image or text classifier or recommender system, style transfer and object detection and so on. So it's like a cookie cutter of machine learning. You can think of it like that. You can easily make custom models, but only within the provided template. So just a brief comparison. CreateML is like a drag and drop tool with GUI. It requires almost no code. But Turi Create, on the other hand, is a Python framework. So you have to write some Python code. And but you don't have to be like a Python expert. It's really simple. And also it can run on Linux and Windows, so we can train the models on like NVIDIA GPU, which will speed up the training really fast. And then, so for me, the Turi Create was the only viable option because the Create ML didn't have the style transfer template. So I decided to go with Turi Create. So first things first, I prepared the data. Style images are my dollar bills. And then for content images, I found an open source data set of tens of thousands of selfies. Yeah, I was surprised that they actually had that. And to test my result, I handpicked some celebrity photos. So I ran the Turi Create, and like it was like my first time training an actual machine learning model, and I didn't know how long it would take. So I ran the model in my 12-inch MacBook, and it literally took 5 days to get my model. But I was really excited for 5 days, and I waited with patience. And I will show you the result. So the very first model came out like this. So I don't know if you realize that the result is completely wrong, because I want to put the face, right? But the color of the background is into his face. So like the background color and skin color is mixed up, and it really doesn't look like style transfer. It looks like 5-year-old just colored it with yellow crayon. So. But I found out that I wasn't the only one experiencing this problem. So I Googled, and since Turi Create is an open source, there's a GitHub repository, and there are many issues. And this was one of the issues. So one person put it up there that he or she ran the model, but the result was not as expected. So I didn't really know what to do from now on. So I received some help from my friend who is an ML engineer. And he actually looked into the code, into the Turi Create framework, and actually found some undocumented parameters that we can tweak around. So it was strange that these aren't mentioned in Apple's official documentation. But eventually these 4 parameters played a crucial role in getting the result I wanted. So style loss multiplier is an array of floats. It serves as the coefficients of 4 convolution layers. So convolutional layer is a special type of neural network layer used in image-related deep learning, for those of you know. And fine-tune all parameter is a Boolean value whether or not Turi will train feature extractor. So if you train feature extractor, instead of using the default provided by Turi, the result came out better, but it takes longer to train. And input shape is the size of the images that the model will use. So in general, it is 256 by 256, or you can choose 512 by 512. But oddly, like larger image size doesn't necessarily guarantee better outcome. And lastly, use augmentation parameter is used to determine whether or not to augment the training data set. And if this value is true, then Turi will automatically generate new training images by rotating or flipping the images that I provided. So this is the common practice in machine learning, where more data often yields better results. So for more information, you can check out this blog post written by my colleague. He explains these parameters in great detail. And this is a final code that unleashes the power of hidden parameters of Turi Create. And with this, I ended up training 180 different models with all the different combinations of those parameters. And this time I didn't use my 12-inch MacBook, so that would have taken me 800 days, so that's impossible. So instead I used this cloud GPU platform to train several models in parallel and on GPU. So each model took about 2 hours to train on the GPU. So, and there are several online platforms that support this, such as Amazon SageMaker, Google Cloud ML Engine. However, I actually didn't use this because our company had its own for like internal usage, so I was lucky to utilize that. So these are some of the end models I handpicked. So you can notice like small differences depending on what value I put into the parameters. And you can see that some have like deformed shapes, some still has the skin color remaining, and like this is the tricky part of style transfer. So other machine learning models they have a metric called accuracy, but for style transfer you just have to look at it and pick the one you want. So after all these, this is my final outcome. So through trial and error, you can see that I removed the background, like at all. So I just had to like really close, take a picture of the person's face in really close up. So that was the final trick. And this is Korean one. So you can see the color differences really well for this for a Korean build. So when you generate the model with Turi Create, the end product is this ML model file. Then you can simply just drag and drop into your project. And it gives you this nice overview of the model, such as size, which in my case is 6.9 megabyte, which is pretty awesome for ML model. And one of the biggest advantages of using Apple-provided program like Create ML or Turi Create is that it is optimized for mobile device usage. So the size and memory usage is really it doesn't go through the roof. So actually, one of the initial models I downloaded from internet that was made by using PyTorch, it used 1.2 gigabytes of memory when I ran the model. So actually the app crashes because it exceeds the memory budget allocated by iOS. And using CoreML model is really nothing fancy. Just instantiate from the model class and call the method prediction. And then just put in the parameters, image, and the index. And be careful to run this on a background thread because if the computation takes long, it's going to block the main queues. And you can also run ML model using VN Core ML model, which is part of the Vision framework. It's a kind of request that is specialized in image-based request. So far we've come to this. So after the user takes a selfie, I run the style transfer model to stylize the image first, and then I run the ML kit face contour detection to crop out the contour of the face. So now all that's left is anchoring this image into the build. So that's when the ARKit comes back again. So when ARKit detects the image, it provides AR image anchor instance through this AR STCN view delegate method. And AR image anchor is just a subclass of AR anchor, which just represents position, orientation, and scale of the object in the world coordinate. And each AR anchor is mapped with SceneKit's SCN node. And I can display these digital 3D objects or 2D objects using this SCN node instance. So to display my 2D image onto the face, I create the SCN node with geometry of a plane, and then I texturize this plane with the face image, which I turned into UI image. and then put that value into geometry.firstMaterial.diffuse.contents. So if I return this node for my AR image anchor, the SCN node will automatically stay in position with alongside with the AR image anchor, which is my bill. So it creates this cool AR effect that the face is attached to the bill in the real world. So that's it. So these are like some final results of my faces on the bill. And these are my friends on Korean bill. Yeah, to sum up, ARKit image tracking, it really feels like magic. And real-time face detection for better and consistent user experience. And then artistic style transfer made in Turi Create, run with CoreML. And then face contour detection by MLKit by Firebase. And then finally anchoring the face onto the bill using ARKit and SyncKit. So these all came together to make this app. Yeah, so that concludes my talk, and hopefully this talk has inspired you to integrate or make your own machine learning models into your app. Or, yeah, because, I did it, so it's really easy, so you guys can do it too. Yeah, thank you very much.